In this class, we are going to discuss about the three-phase off-wave control rectifier with RL load, continuous current mode. Here we have taken the firing angle alpha equal to 60 degrees. The input is the three-phase voltage VA equal to Vm sin omega t, VB equal to Vm sin omega t minus 120 degrees, VC equal to Vm sin omega t minus 240 degrees. Take the scale, draw the phase A voltage, phase B voltage and phase C voltage. So here we have taken the firing angle alpha equal to 60 degrees. From 30 degrees onwards, phase A maintains more positive, so the SCR is forward bias. The firing angle applied to the T1 is 60 degrees. So 30 plus 60 nothing but a 90 degrees the T1 is on. Once the T1 is on, it has to conduct a 140 degrees because it is a three-phase system. So up to this point, T1 is conducting. At this point, T1 will be off and T2 will be start conducting. Again it is conducting 120 degrees. Next 120 degrees T3 has to conduct. Now we are going to develop the output voltage waveform. At this instant the T1 is on, so the load voltage is equal to phase A voltage. From this point you have to see how the phase A voltage is changing up to this instant. You take up the same waveform, same magnitude. Even the output voltage is negative, the T1 is forced to conduct because of this inductance. At this point, T2 is on. Once the T2 is on, the load voltage is equal to VB voltage. From this point, you will see how the VB is changing. This is the VB voltage up to this point. The same manner, you have to draw the output voltage when T3 is conducting. So, this is the output voltage waveform. This point we can write it as a pi by 6 plus alpha, and this instant we can write it as a 5 pi by 6 plus alpha, where alpha we can change from 0 to 100 degrees. But in this case we have taken the alpha equal to 60 degrees. Now we are going to draw the output current waveform. At this point you have taken the minimum value of current because we have taken the load current as a continuous load current. As long as the load is subject to positive voltage, you increase the current. When the load is subject to negative voltage, then you have to decrease the current to the minimum value. Again the positive voltage applied, so it increases, decreases, increases and decreases. This current is nothing but a phase A current. This current is nothing but a phase B current. This current is nothing but a phase C current. Now we are going to draw the source current phase A. From this instant to this instant, phase A is supplying current. So remaining duration, phase A current becomes a 0. You take up the same magnitude and same wave. Phase B. Phase B is supplying a current from this point to this point. So you draw the same waveform and magnitude in this duration. Remaining duration, phase B is not supplying any current. Similar manner you have to draw the phase C current also. Now we are going to keep the circuit operation in the table form. 90 to 220 degrees, T1 is conducting, load voltage becomes a phase A. 210 to 330 degrees, T2 is conducting, output voltage becomes a VB. 300 to 360, T3 is conducting, output voltage becomes a VC. Again from 0 to 90 degrees also T3 is conducting, the output voltage becomes a VC. Now we are going to find out the average output voltage. The base length becomes a 120 degrees. So 1 by 2 pi by 3, 3 goes to the numerator. So 3 by 2 pi integral pi by 6 plus alpha to 5 pi by 6 plus alpha Vm sin omega t d omega t. If we complete this integration, we are getting this exponent. And use this formula and find out the expression for the average output voltage, that is 3 root 3 Vm by 4 pi cos alpha. The same circuit operation for the RLE load also with a continuous load current. RLE load means here you take the voltage source. Thank you very much for watching this video.